Take a second and try to group these items. Notice that you may do it by shapes. We got triangles, a couple rectangles, and finally some circles. But someone else may sort them by whether or not they're edible. Both methods create perfectly valid groupings, yet yield very different perspectives. This reveals a fundamental question. How do we label anything when so much depends on the viewpoint? To develop a universal language, one that transcends our personal idea spaces, we need to introduce the concepts of closed, open, neither, and Clopen. Recall from our previous videos that your idea space is a physics-based model of the mind, which consists of your thoughts, emotions, sensations, perceptions, and the empty set, or the absence of anything. We also learned how an idea space can have zero measure, which means that it looks like nothing to an outside observer, yet be uncountably deep or always changing and impossible to fully list. Now we'll see how your idea space can also be closed, open, somewhere in between, or even both at once. And if you want a more thorough overview on this, then check out the white paper linked below. Mathematically, a set is closed if it includes all of its limits or boundary points. Think of a radius of disk 1 that contains both the interior points and the points on the boundary. Clearly, it's closed. We can do the same thing with the number line from the points 0 to 5, where here the brackets indicate that the set is closed and the points 0 and 5 are included in the interval. A closed idea space mirrors a closed mindset where every thought or feeling you feel is fully contained. Sometimes you want closure or intense focus. For instance, when you're nearing the end of a project, it's better to avoid new ideas that could completely derail you. This closed approach can be good when used wisely, as it channels your ability and mental energy towards what's already present without letting in new distractions. In math, a set is open if it doesn't contain all of its limits or its boundary points. Think of a disk that includes the interior, but not the outer edge. You can approach that edge forever and ever, but never actually reach it. We can do the same thing with a number line with the set of numbers from 0 to 5. Here, the parentheses indicate that the set is open. The points 0 and 5 are not included in the interval this time around. In an open idea space, you're constantly discovering new thoughts. The boundary keeps receding, and as you near one insight, another one emerges. Think of starting to learn a new subject. Each discovery leads to more questions. This open mindset is great for creativity, but can get overwhelming if you never create boundaries to finalize your tasks. Naturally, some sets are neither fully open nor fully closed. A disk that's open on one edge and closed on the other, or a line segment that's closed on the left and open on the right. In idea spaces, you might have a mental boundary on one issue when there's no more room for discussion, but keeping an open channel for basically everything else. Now, unlike physical doors, a set or even your idea space can be both open and closed simultaneously. This is where the magic of Clopen comes in. Think of the famous internet dress. Some see it as blue and black, others swear it's white and gold. It's the same exact image, yet two realities appear. This is Clopen, a situation where contradictory viewpoints coexist. As Niels Bohr, the father Adam, once said, "The opposite of a correct statement is a false statement, but the opposite of a profound truth may well be another profound truth." To get to Clopen, we must first understand complements. A complement is what remains in a set when I take part of the original set out. For instance, if I take out the apples from the set of fruits, then the set of apples and the set of pears are complements of one another because they make up the whole set when they're together. Overall, the key is openness is dual to closedness. The complement of an open set is closed and the complement of a closed set is open. For instance, if I take an open disk that doesn't include its boundary out of a filled space, then the remaining boundary in the filled space is closed. Conversely, if I take a closed disk that does include its boundary out of a filled space, then the remaining boundary in the filled space is open. We can do the same exercise with our number line from before if we want to. By taking out the open interval 1, 2, we're left with a closed interval and what's left over that includes 1 and 2. By taking out the closed interval 1, 2, we're left with an open interval and what's left over that doesn't include 1 and 2. By understanding the complement of an open set is closed and the complement of a closed set is open, we can now uncover Clopen. Let's take a look at two sets. One contains everything called E and the other contains nothing. Clearly, everything is closed because it contains all of its limits, every point. Nothing, or the empty set, is also closed because it trivially has no limits to include. Everything and nothing are both closed. Naturally, everything and nothing are complements of one another, so Their respective complements, nothing and everything, must be open. Hence, everything and nothing are both open and closed, or Clopen. I know that can be a bit of a mind so let's illustrate the point another way. Imagine taking nothing out of everything. Since everything is closed and nothing is closed, everything becomes open. But since you took nothing from everything, then everything remains closed. Thus, everything is Clopen. And since nothing is the complement of everything, then nothing must be Clopen too. Boom! Double Clopen! Thus, both extremes, everything and nothing, are Clopen. From now on, we'll use this symbol to represent Clopen, a closed set with nothing being taken out. A Clopen idea space helps us see the world beyond simple labels. It's open to new ideas, yet closed in that it feels complete. As Zen master Song San Sunim once said, there is no right and no wrong, but right is right and wrong is wrong. Clopen allows both. Dualities like good and bad, fast and slow, or even open and closed can coexist in the same realm. As philosopher Alan Watts once said, duality arises only when we classify, when we sort our experiences into mental boxes, since a box is no box without an inside or an outside. By understanding Clopen, we're able to take a step back from duality and experience non-duality, or Clopenness. Continuing Watts' sentiments, the non-duality of the mind, in which it is no longer divided against itself, is samadhi. And because of the disappearance of that fruitless threshing around of the mind to grasp itself, samadhi is a state of profound peace. Clopen is a revolutionary concept that unites mathematics with real-world paradoxes. Like we talked about in an earlier video, the foundation of physics is mapping mathematical concepts onto observations. And Clopen can be found everywhere in life, like the dress. For instance, Clopen helps us explain the conundrum of mind-body duality. Are we controlled by our body filled with trillions of cells and bacteria? Or are we controlled by our idea space filled with uncountable thoughts, emotions, sensations, and perceptions? Well, both. The situation is Clopen. Clopen also helps describe the phenomena of particle-wave duality from the famous double slit experiment we'll cover in a later video. Overall, the question is, does light and other elementary particles from the standard model responsible for the fabric of space-time act like a wave or a particle? Well, it depends. The situation is Clopen. Clopen can even explain free will. Do we possess free will and the ability to make conscious decisions, or are our actions predetermined by a series of random events? On one hand, when geneticist Robert Plomin describes DNA, the building block of cells, he states, the single most important thing to know is that DNA consists of dumb molecules that blindly obey the laws of chemistry. If quarks are dumb molecules that blindly obey the laws of physics, if DNA are dumb nucleotides that blindly obey the laws of chemistry, if cells are dumb organisms that blindly obey the laws of biology, then are we dumb humans that blindly obey the laws of the universe with zero free will? On the other hand, is it possible that free will is a simple act of shining the light of mindfulness onto an idea space? Thus, when faced with choice points, is our free will to choose the future event we desire based on our past and present? Then, if every single moment of our lives is a choice point, does free will occur all the time? In true fashion, the situation is Clopen. We both have and don't have free will. Clopen is the trivial mathematical finding of our generation. It challenges our preconceived notions that things are either closed or open by showing that most things in life are either closed, open, neither, or Clopen. The rigid categories we place on reality are simply veils of illusion. Life is definitely often more nuanced than simple binary labels, as you very well know. If you want to explore a little bit more about how Clopen relates to your idea space, then check out the Idea Space book, link below. And if you enjoyed this video and exploration of Clopen, open, closed, and neither, then make sure to like, subscribe, and hit that notification bell so you won't miss the next videos on the observable universe, the Big Bang, and star formation. I shall see you later. Thank you for tuning in. Bada boom, bada bing, adios. Peace.